Hello, and welcome to our webinar, IoT and Developing Analytics-Based Data Products. My name is Steve Paul, contributing editor at MIT Sloan Management Review, and I'll be your moderator today. We have just a few announcements before we begin. This event will be recorded and will be available to all attendees approximately 3 to 4 business days after the end of our event. In addition, today's slides will also be made available to attendees. We welcome your questions for our sponsors and our speakers today. To submit questions, please enter them anytime in the chat box in the lower corner of your screen. Or you can submit questions on Twitter using the hashtag MITSMREvent. We'll answer as many questions as time permits after our presentation. And if you're having any audio difficulties while listening via computer, please call in via telephone instead, or check the help link in the upper right-hand corner of your console. Our speakers today are Thomas H. Davenport, the President's Distinguished Professor of Information Technology and Management at Boston College, and a Fellow of the MIT Initiative on the Digital Economy. We also have Stephan Kudybadiscuss, Associate Professor of Business Analytics and MIS at the Martin Tuckman School of Management at the New Jersey Institute of Technology. And now we're going to start with our presentation, IoT and Developing Analytics-Based Data Products. So let's begin with Tom.
Today, and to talk about this interesting topic. So I will kind of introduce the topic and give some examples, and then Stephan and I wrote an article about this topic in the Sloan Management Review recently, and Stephan will give you the sort of framework and the development process for this thing we call data products. The data economy is really the general context for which we're talking about these topics today, and information in this economy has been called the new oil, but like oil, it needs some work. It needs to be refined and distributed and consumed. We don't have the equivalent of refineries or big trucks or pipelines or even automobiles for this data-based economy. So some of those things need to be developed. In many cases, of course, organizations are going to want to monetize some of their vast data assets, just like we monetize oil. And a key way to do that is to create some data and analytics-based products and services. Analytics in particular, and data to a large degree as well, have been used in the past primarily for internal decisions and transactions in the case of data. But in the data economy, more and more organizations are saying, how can we develop products and services based on data and analytics that are of value to our customers? So kind of taking an external perspective on these capabilities. A number of organizations don't yet have the maturity, I guess, to actually charge for these products and services, but it's pretty easy to use them to catch eyeballs, to attract and keep attention. And since many online business models are based on advertising, that can be they can lead to a monetary good as well. And in some cases, what we're doing is helping customers use data and analytics to make better decisions about the products and services that we might sell them. So these are just some of the ways that organizations are beginning to compete in the data economy, although it's very, very early days, I think it's fair to say. So the Internet of Things, like the data economy, is also in its early stages, and we are just beginning to think about how do organizations develop business models and make money with the Internet of Things. It's clearly a massive new source of data with billions of devices connected to the Internet. In order to really get value from the Internet of Things. We need some level of analytics to make sense of all that data and to take intelligent action on the data. And in order to do the analytics, we have to get the data ready. And I think one of the sticking points right now for the Internet of Things is that there's so much data in so many different formats that if we're talking about managing a high-level platform in the physical world, say a car or a home, we have a lot of data integration to do. The average car, for example, has about 200 different sensors today, and a friend at MIT who counted said there are about 195 different data formats. So making sense of all that data is going to be quite challenging over the next several years, but I think it can be done, particularly with cloud-based platforms for data transformation and interchange. But even today, we have some targeted and company-specific data products available for the Internet of Things data, and we'll talk about those. So you may not be able to manage your entire car, but you can at least manage some driving behaviors, for example. So how do we monetize data in general? Well, we can sell data directly to customers. That's been going on for a while, of course. The focus that we're taking, though, is selling data products. In many cases, those data products have analytics embedded in them, as you will see when I start giving examples in a minute or two. We can take existing data and analytics. We can take existing products and services and embed data and analytics within them. I mentioned the advertising-based model where what we really do is attract eyeballs to online customers and eventually charge for those eyeballs through advertising. There are sort of platforms of various types, one-sided platforms, two-sided platforms, trading platforms, and so on that have various types of data embedded in them, so we can provide access to those platforms. Maybe apps are a simple example of those. Or we can, again, go internal and say, how do we use data to improve our internal business processes? So those are just some of the ways that organizations monetize data. And the model for this idea of data products really comes from the online industry, something that was developed in all these companies, most of which are from Silicon Valley, not all of them. I think Zillow is from Seattle, but Google, of course, has a whole host of data products, starting with search and going into some advertising-oriented ones, more narrow ones like Google Books and Google Maps and Google Scholar and so on. Hal Varian, the chief economist of Google, I once asked him, how many data products do you have? And he said, well, go to Wikipedia and look up Google and look at all the products we have and count them, and that will be the number of data products that we have, which I thought was kind of a smart aleck answer, but perhaps a true one. LinkedIn pioneered the people you may know idea, one of its most popular data products, and they have a number of other related offerings like that. They estimate that people you may know is responsible for about half the members that they have. Netflix, of course, some ratings-oriented data products. Zillow, many of you may check on your housing value through the Zestimates application. Again, they don't charge for it. It just brings in eyeballs, and they've done various other things as well. And Facebook has gotten into this with some people you may know kinds of applications, and then some advertising-oriented ones more recently. So a lot of these things in the online world, but the interesting thing is that we're starting to see them offline as well. So Google's Nest, of course, has some data and analytics built into it based on your own thermostat, your own heating and cooling, but they also sell those analyses to utility companies. Fitbit starting to bundle in a Fitbit with data on how people are using it and exercising or not, and selling that to companies, and health insurance companies are using it to offer discounts. One life insurance company offers discounts as well. And we, of course, have various types of smart sports equipment, the smart soccer ball, the smart basketball that will tell you how best to shoot. I think there's a smart baseball now as well. We have various bathroom-oriented products. I won't go through them in great detail. I am not entirely convinced that I want to tell my dentist how often and how long I brush every day, but that option is available through the Philips Smart Toothbrush. And you see this on the services side as well, and on the B2B side, where it's a transport company providing shipping data to various stakeholders, and when a ship is coming in. You're starting to see, in terms of services, insurance companies developing driving advice. You could drive more safely if you accelerated more carefully or decelerated less dramatically, for example. Or this pay-as-you-drive or usage-based insurance information yields data on when people are, when their car is broken down or when they have an accident, so they can dispatch a tow truck without you even having to report it. Of course, there's a lot of directions-oriented advice these days from Waze and Google Maps and others. Delta Airlines just announced a couple of weeks ago a RFID-based, which was really the first version of the Internet of Things, RFID-based tags that will tell you where your bag is at any moment, and you can find out whether your bag actually made the plane that you are on, although you may not find out, since you have to turn off your smartphone, you may not actually find out until after the flight has arrived at its destination. But I guess that's useful information. And then in trucking, increasingly, we have all sorts of detail about where trucks are. Schneider's one of the big truck lines in the United States. They monitor driver safety, acceleration and deceleration and so on. They optimize the refueling locations based on prices at truck stops and things like that. So these are really early signs that we can get some dramatic value out of the IoT. So perhaps the most commonly used example, I didn't want to neglect them, is GE, which is really using the IoT for, and you might call it more data services rather than data products, because basically what they're doing is taking their existing products, embedding a variety of sensors in them, whether it's a jet engine or a gas turbine or a windmill or an MRI machine, putting in those sensors so that they can service them more effectively. And in their industrial businesses, they get most of their revenue from services anyway. So if you can optimize how those services are delivered, in many cases they're even changing the business model, so they're not selling a jet engine. What they're selling is an amount of thrust, for one airplane trip. So they're really taking over the device and the servicing of it, taking that off the hands of the customer if they're willing to do that. In doing so, they had to develop some new platforms, Predicity, which is an optimization and prediction platform, and Predix, which is a data integration platform. Both of these have had some success in the marketplace, and the company was already selling some software and data products, but the amount is escalating dramatically. They estimate this year there will be about $6 billion in software and data products, and also increasing their service margins pretty dramatically too. So that's a big success story. Progressive is another company that has historically made a lot of use of data. It's, of course, property and casualty insurance company, mostly focused on driving oriented automobile insurance, and they were the earliest adopter of credit scores to predict your driving behavior. Turns out, your financial risk is a good predictor of your driving risk, but they've been at this idea of usage-based insurance or pay-as-you-drive insurance for a while. Now they call it Snapshot. It's gone under various names over its history. It's available in most states in the U.S. About a third of new customers seem perfectly willing to have their insurance company spying on them in exchange for substantial discounts if you're a good driver. It's yielded about $2 billion in premiums in 2013 and even more now. It turns out that while credit scores are a good predictor of whether you will crash your car or not, actual driver behavior is about 25% better than credit scores as a predictor. And now they have about 10 billion miles of data to analyze. So that's all very useful, and it's all for internal processes like pricing and underwriting. But they are actually piloting some services related to the smartphone as a data gathering device instead of having to send you one. And of course, these devices have accelerometers in them, so we can monitor how someone is accelerating and decelerating. But they also can do things like monitor, how your car is shaking, so they could identify the need for, a front-end alignment or other, problem in your engine, or as I mentioned earlier, road assistance. So you can start to imagine how, although it's very early days for this, that the IoT in its various forms could be a fantastic way to start to develop some new products and services that you could offer to customers. And we're just seeing the beginnings of that with Progressive now. So I'm going to turn things over to Stephan now, who's going to tell you a little bit about this framework that we didn't totally invent, but we at least augmented for thinking about this issue.
Thanks a lot, Tom. Yeah, we're going to change the emphasis a bit towards the conceptual side of how we put our article together. Basically, we leveraged the classic article by Meyer and Zach, the design and development of information products. And they had a really unique 5-stage refinement process to take all these digital, or back then, data assets and create an information product. Just hit the next slide, Tom. And the 5 stages they had were, there we go, acquisition, refinement, storage, retrieval, distribution, presentation. I don't want to go too much in detail, but I'll just give you a quick background of what they were. Acquisition, basically, in their model, entailed sourcing data, gathering all the available data to create an information product. The refinement process was data management, normalization, and various analytic methods applied to it. Once a product's created, put it in a storage device so it can have flexible retrieval, and once that was in place, you had your distribution process, how it was distributed to the ultimate marketplace, and then presentation was interesting. What was the final form of the information product? Was it a static report? Was it an interactive report? Did it have some what-if or some predictive capabilities? We're going to talk about that a little bit more in the next few minutes.
So, yeah, I'll just say one thing, Steve, which is it's important to remember that they identified these, Mark Meyer and Mike Zach identified these stages before we really started to see the development of internet-based offerings. So they were really talking about, things time-shared or AOL related kinds of things. Internet wasn't in wide use at the time. And we thought, well, it's not a widely cited article, we thought that it was actually before its time in many ways.
Yes, it's a good point. It's still extremely valid even in the digital era where we're entering right now. And it's true that when we're talking about data resources back in the mid-90s, it's apples and oranges now compared to what we're looking at. And we're going to hit that in the next few slides. So let's go to the next slide there. So what we did with, like I said, we leveraged their work, and we added a couple of stages to the process in this data product or information product creation model, so to speak. We added at the front end a product conceptualization stage. Given we're in this this heavy digitalization or this Internet of Things type of era, the data resources are so much more complex than they were back in the mid-90s. You've got structured, unstructured, the 3 V's or 4 V's of big data. Before you jump in and say, we're going to create a data product, you really need to conceptualize what this product's going to be and create a prototype, so to speak. That's the first step that we added, and then we kick into the next 5 of the Meyer and Zach, with some augmentation, of course, because it's, we're in a different era now. And on the back end, we included a market feedback mechanism. Again, because we're in the internet era, the e-era, the digital era, there's so many ways to keep in touch with the marketplace, to collaborate with the ultimate consumer, to identify or just generate knowledge based off or understand what the market needs. So you're not just rolling out a product that's going to be sitting on a shelf. It's going to be a product that actually adds value to the ultimate consumer. So our model is a 7-stage model, and as I'll explain in a few slides from now, it's a closed loop. It cycles. It never really stops. Given the potential of the value of information products, this should be an ongoing process for many organizations in this big data era.
We should also say that while we observe some of these stages taking place in the real organizations that we studied for this research, the product development processes that we saw for most organizations for data products were not very well organized. They were very casual. It wasn't clear what the key steps were. Some steps would get skipped. So we thought that a higher level of rigor in process models, although people want to move much faster these days than maybe they did in 1996, a higher level of rigor would probably yield more successful data products than the ones that we saw.
That's true. Rigor in the process, and also, as we'll talk about in the next few slides, the rigor of input, stakeholder input. It can't just be the data scientist's job to do this whole thing. It's you need cross-functional, cross-organizational input to really nail down a product that's got value. It's another big part of this process. So, all right, go ahead, Tom. So on this this conceptualization stage, this prototyping, it entails a couple of things. Number one, the skills that can manage data are much more complex for data management professionals, analysts, data scientists, and now, 10 years ago you didn't hear of the term data scientist, and now it's one of the hottest terms out there. In conjunction with that, you need input from subject matter experts, from marketing departments, that type of thing, to come together and create a prototype. What's this information product going to look like? And what adds even more complexity to it, this is a lot of competition. There's a lot of organizations looking to, hate to use the word cash in on a good data or information product, but yours has got to be unique. And there's so many data sources out there, whether it's structured, unstructured, streaming data, what have you. You've got a science of analytics, an art of analytics, and I like to focus on the art because not too many people do these days. So when I consider the art of analytics is thinking about all the data sources that are out there and identifying variables that can really add value to models, to information, or data products. Consider on the bottom of the slide, you see weather patterns. I mean, if you looked at retail activity and you wanted to estimate, each retail activity for stores or what have you, 10, 15 years ago, no one would even consider using weather pattern data or foot traffic data for potential retail sales. If you want to understand consumer behavior, now you can monitor keyword search terms on the internet. Again, 15, 20 years ago, you wouldn't even consider it. The commodity based for crop yields, soil fertilizer, seed depth, watering quantities. All these processes now are being digitized. And the real, I'd have to say the complexity, but also the potential is this conceptualization idea. How do you source the variables, the data that's out there, and how do you put them together in a coherent way to make a really neat model, a really neat product? Data is being created every day, every month. This is the thing: staying on top of it, and putting it together, and create some value for the marketplace. All right, next slide, Tom. So that's the back end. The first on the conceptualization is the front end. Now the back end to our research was understanding the marketplace, and what we've had is another surge in marketing research or market research tactics. There's new ways of staying on top of the market to extract information. This knowledge generation process. We got Tom, the expert on this knowledge management thing, but knowledge generation process of understanding what the market wants. Whether it's a B2B client or a B2C client, what are they looking to pay for? What do they see value in? The way to do it is to monitor it. So in our model, we said, okay, well, the information product, the data product's created, we delivered it to the marketplace. We just don't walk away and say, yeah, that's done. It continues. Two things, pieces of information to extract is, number one, do you see value in that information product? As far as developmental goes, how can we tweak it? How can we tweak it to make it better? And what new products can we bring to you on an ongoing basis to meet the needs of the market? And here's where the stakeholders. In fact, the whole model really incorporates stakeholders across the organization. And again, it's a lot of let's say focus has been on decision scientists or data scientists. There's more than that. You really need the expertise of various functions in an organization. I like to call it subject matter experts, but again, marketing departments, areas that have contact with the marketplace. You got to leverage that information, that expertise, in conjunction with data management professionals and of course the data scientists. Okay, next slide, Tom.
Yeah. Let me just give one quick example of where you have to be careful with this relationship. So at LinkedIn, where they were thinking, a guy named Jonathan Goldman, a data scientist, as Stephan suggested, was developing this capability for identifying people you may know. And he actually mentioned it to some other stakeholders and people who own the product, basically the LinkedIn product, and they said, we kind of have that already. We don't really need it. He didn't believe that they did. So he went to Reid Hoffman, the co-founder, and said, I think this could be really, really great. Can you protect it for a while as I develop it further? And he did, and then they insisted that it be added. So you can't really do it as just a data scientist alone adding these capabilities, although you may have to sometimes use some creative means to get around some of the other stakeholders.
Okay, and that's I mentioned before this kind of resurgence of market research. It's there's so many ways to tap on the marketplace, whether it's the ultimate consumer, the B2C, or even your business consumers. The new IT and IS platforms are just if you leverage them strategically, it's an easier way to extract information from the market. Crowdsourcing has become let's say a prominent way of getting feedback from the market. Flash surveys, in conjunction with the old traditional survey method, but things like flash surveys have used the faster digitized e-platforms to get quick responses from the marketplace. Other things, blogs, business Facebook pages, of course smartphones and classic email, all ways of querying the market, querying your customer, and getting bits and pieces of information back to really understand what's going on. And a couple of examples I put down: General Mills leveraged the web platform for Worldwide Innovation Network, their GWIN, to partner with individuals or innovative companies for food processing, new food processing ideas and innovations. If you've noticed, the craft beer segment has just exploded in the last year or so, and Anheuser-Busch leveraged crowdsourcing to say, hey, what type of craft beers? How do we embrace this new trend in the marketplace? And they used a crowdsourcing type of approach to figure out which craft beers to go after and to brew. So with this market research, or these tactics in leveraging information from the marketplace, it creates a closed loop for our article, our research. Okay, we go through the first 6 steps, and actually it's a good segue to the next slide, Tom. I think we.
How long do you think it'll be, Stephan, before we have an IoT connected beer can, so you can gather data on with what level of gusto that beer was consumed?
That's not bad. Although I don't want to connect it to a demographic, I don't think. But
Yeah.
all right, yeah. Well, we'll see. We're going to go into some AI later in this, and it'll scare some people out there. Actually, one way to kind of simplify this data product issue, because there's so many data sources, resources out there, identify a metric of interest. Identify a performance metric, interest to whether it's, again, a B2C, the personal consumer or the business consumer. And when you identify that metric of interest, then it simplifies let's say, the creation of the data product. I'm into the data mining space in a big way, and I say the same thing when you do data mining. Think first, analyze later. Think first, mine later. And that thinking first says, what do you want to better understand, or what piece of information do you want? Same thing with a data product. Everyone wants to know something. There's this hot metric, and if you identify, define that hot metric, then what you do is you source data for variables that impact that metric or fully describe that metric, and now you've got a really cool data product. Again, in the shipping area, hot metric is if you're looking to ship product, you want reliability. You're going to ship it across the world. You're going to ship it from LA to China or what have you. You want reliability. I want to know when my product is going to get there for supply chain, what have you. If you can come up with a metric that tells you the reliability of ship time and the factors that could impact it, now you've got a nice data product. As Tom said, sensors, just being included in so many products these days. But if you want to think about Fitbit users, what's the real hot metric? What's the information people are looking for? Well, what activities yield the highest caloric burn, right? Whether it's, if you're Fitbit users, you're all looking at your watch saying, oh, gee, I've got to do another 500 steps today because I'm behind the wheel or what have you. But it's that metric. It's that metric of interest. Once you get that, then you can roll with the product. Other areas evolving, surveillance technology. Metric of interest is, how do I price my retail space if I'm a mall, or if I'm looking to rent retail space at a mall? What am I going to pay? Well, now you have traffic patterns, foot traffic patterns on an hourly, daily, weekly basis from surveillance technology. Sensors in roads for smart zones. We're talking about smart cities as smart zones. What is a smart zone? What's the metric of interest? Where's congestion in my area? Where's congestion in my municipality? Congestion is not good for anybody. It's not good for drivers. It's not good for people who live there, for carbon emissions, that kind of thing. So here's the metric. Congestion during what times a day? Well, now what variables impact that? Give you a description to create this data product. And what's the actionable data, meaning, all right, you've got your congestion zone. What do you do with it? How do you reroute it, so to speak, with civil engineering tactics, that kind of thing. So that's the back end of our model. Now I think we've got the closed loop. So if you can hit the next slide, Tom. There it is. There's our closed loop. So just to kind of put it all together, you've got on the bottom our first step, conceptual modeling. Because of all the data sources in the digital era and all the analytics capabilities, you've got to sit back and you've got to put some structure behind it. Structure behind this idea of putting a product together, but it's a different kind of product. It's not something you touch and feel. It's an information or a database product. Now you've got a dual input into your acquisition and refinement modes. As you're doing this conceptualization, which includes an art and a science, you've got to go out and consider where the data is. All right, there's data internal to an organization, external to an organization. You've got all types of big data, and you can't think out of the. Let's say you've got to consider the refinement process at the same time. All right, you've got to consider how is it going to. What do we need to do to tame this data, to store it, to normalize it? Can we even use some of these data sources, because some of it's streaming, some of it's so unstructured, we're not sure if we can add structure to it. So those three right there, the conceptualization, acquisition, and refinement, is almost an ongoing, it's such a fundamental to this creation process. Storage and retrieval, that's pretty much a given once your product is created. Your product distribution, we have augmented the Meyer and Zach approach simply because of technology. They were talking about fax and CD-ROM back 20 years ago, and you can't blame them. That's what they had. We're all E-based now. The presentation also is added a lot of complexities. All right. Think about the app market. All right. Just incredibly huge market as far as development and type of apps. Think about the functionality of an app, which is a form of a data and information product. It's predictive, it's interactive, it's got massive search capabilities, algorithmic, that kind of thing. So now you're presenting it to the marketplace. You also have to consider how is that market going to access your information product? Something you didn't have to think about so much 15, 20 years ago, or even 10 years ago. You'd say, well, people are just going to log on their computer and they're going to look at the product. Well, now research has shown most people are using smartphones. And what's a problem with smartphones? Well, you got a screen that's a lot smaller than a computer. So if you're going to design an information or data product, that thing's got to be visible, and it's got to have great functionality at the smartphone level. So there's another bit of complexity to the original research. Finally, you deliver it to the marketplace. You've got your ongoing market research. Did we provide the functionality you want? Did we provide the information you want? How can we tweak it? Because we can tweak it fast, because everything's fast these days. And additionally, what else can we give you? And as that information and knowledge generation process is ongoing, it just loops right back into the conceptualization process. It's a nice closed loop, connecting what does the market need to conceptualizing another information product. I would tend to think as time goes on, the digital era continues to surge, the data and information product, the demand for this stuff is going to intensify, and this model is a nice way to keep this continuous cycle in motion.
And you can do it, and you could do all of these steps in a relatively short time. I mean, when we talk to companies, many of them were quite big fans of the sort of lean startup model with a minimum viable product and so on. But this just starts to say, okay, say you develop a minimum viable product based on what you think the market wants. You have these other steps you need to pass through, and then it leads you to refinement of the minimum viable product to make it much more valuable and useful for customers over time. So the fact that we have all these steps doesn't mean that you can, afford to take years to do it. You may need to cycle through a number of product iterations before you get something that you are happy with or that your customers want to use.
Okay, move on to the next slide there. All right, I just wanted to add just a few comments on some additional modifications to the original Zach Meyer approach. They had the 5 steps, and again, we're talking 20 years ago, and things have changed so dramatically. But their original acquisition stage has grown. Our digital era has introduced so much complexity, and we all know big data now, the 3 V's, or some people say the 4 V's. But I'll just kind of focus on a little bit. There's internal sources of data to an organization, data that an organization gathers on an ongoing basis, but there's more and more external data being generated. External being GPS or satellite generated, social media, external. These are all tremendous sources of data to combine with internal to create these great robust products. Structured data, we all know, it's easy to work with, it's categorized, it's storable, but now you've got this wild thing called unstructured data, and that's verbiage, images, speech. 20 years ago, you wouldn't even consider unstructured data in your data model or your information product. It's going to be your data product. And unstructured, it's difficult to work with. You may say, hey, there's a great potential source of data or information. Try to analyze it and try to really pull some good stuff out of it. That's it's not that easy to do all the time. Okay, next slide, Tom. On the refinement stage, same thing. Massive complexities in the new digital era. Data normalization, and I have to, I don't want to keep beating the big data term to death here, but it's true. Data normalization in the big data world, you need Hadoop skills or parallel processing, map reduction skills, just to handle some of the high volume, high velocity data. You need data scientists. Again, that's a term that's only popped up in the last couple of years, and I still think it's kind of, if you ask people what a data scientist does or the skills, it's kind of a moving target. There's a lot of skills that are involved in data science, but it's, these are needed, these high-end skills to tame this new data. And of course, you need collaboration with subject matter experts in this refinement stage. But getting into this refinement stage, the realm of analytics is really providing tremendous, let's say, differentiation for data products and information products. Advanced search, there's a lot of technologies. If you, again, go into it, any app, a lot of it is advanced search, interactive, ask a question, and it's an advanced search algorithm behind the scenes that's pulling information and creating a great data product. This one's the hot one, AI and deep learning AI. Tom's been doing a lot of work on how AI is changing labor force and processes and that type of thing. And now with the latest breakthrough in AI is unsupervised AI techniques and deep learning, which have been facilitated by increases in computer processing capabilities. And this deep learning stuff it's high powered. It's adding reliability to image categorization, speech recognition. Those two in themselves, I think, introduce tremendous new avenues for new data products. And again, this is just starting. This less than a year probably in active research. See, a lot of these techniques have been around, but the enhancements in computer processing are just unleashing some of these high-end type of analytic capabilities. And they have text mining, which is complementary, just adding structure to unstructured data. So all the refinement and all these techniques will add complexity to the refinement process. But it's really the bottom, the analytics, that add the true potential differentiation in creating some really interesting data products in the future. Now, do we have another slide, Tom? Let me see.
Yeah, so we want to get to your questions, but just a summary slide. How do you be successful in the data economy with your IoT? Get some good data out of all those sensors. This is going to provide some work for the lawyers who understand who actually owns the data, so make sure you have rights to it. We talked to a number of companies that were still negotiating the rights between themselves and their customers. As I mentioned, there's a lot of integration, cleaning, and analytics capabilities before you can really do data products well. You may want to try them out on yourself first. We didn't make that a specific, an explicit step in our model, but try them out internally first, see how they go. Understand your customers' decision needs and processes. That's the market research area that Stephan was talking about. Eventually, you're going to have so much data that you're going to need to automate some aspects of the process. There's security and privacy issues. You'll get into, what do I charge for this? Do I bundle it with existing products? What are the terms of use? So one of the reasons why I think you need some serious product development muscle in doing this work. And as some companies said to us, these data products, they're the pirate ship, they're not the mothership. We don't want them to cannibalize the mothership. So you may have to deal with some issues there as well about how new data products and services affect your existing business. So with that, we'll stop. We're happy to answer any questions or respond to any comments that you have. And I think, Steve, you're gonna manage that for us.
Right. Great job, gentlemen. Excellent presentation. Very thoughtful. Got a lot of great questions and comments. And so we'll take them up until the end of the hour. Let's get right to it. Something from John here wants to know how are the machine learning disciplines merging with the actuarial black boxes to develop better models? He's seen a fair amount of resistance from actuarials to the ML techniques. Any thoughts on that?
I'll say something about it, and it's certainly early days. I think it's fair to say that actuaries, despite their many quantitative skills, are not renowned for their early embrace of new analytical approaches, and they had to take all those tests, and none of them involved machine learning. I think in many cases, organizations are going to meet some resistance when you start to use new technologies like machine learning. But ultimately, I think given the amount of data that we're getting from the IoT, we're not going to be able to do the traditional artisanal analytics in the way that we have for the last 30 or 40 years. We're going to have to use some autonomous approaches. And if we just think of machine learning as a relatively autonomous approach to analytics, maybe it'll make it easier to understand. So I think I recommend introducing these approaches now in a somewhat gentle way to actuaries and other analytical groups within your company, and maybe over the next year or two they'll get comfortable with them.
Yeah, that's a great response, Tom, with the autonomous type of focus on there. That's been a classic battle. I've been teaching data mining for, I don't know, about 15, 20 years, and I've witnessed the battle between statistical, pure, traditional statisticians and actuaries, and what is this black box data mining stuff. And it's the battles, let's say, it's come around towards accepting some of these algorithmic approaches, and it's going to be difficult to say, well, there's no, we're going to keep fighting. And with the autonomous introduction, I think that's probably the best way to handle the situation. But there's always going to be a little friction there.
Okay, thanks. A number of people are asking about resources, how to read up on the topic, what universities or online courses can they take to get qualifications in analytics. Have any recommendations?
Well, there are a very large number now of data and analytics oriented programs at universities in the US, over 100 degree programs. Some have multiple ones. Last week I was out in California, and both Berkeley and UC San Diego have multiple analytics degrees coming from different schools and so on. And Stephan, I don't know if NJIT has one of these programs, but they are all over the place now.
Yeah, we're introduced to a PhD program in that area, and on top of the focus in our MBA programs, it's nationwide. It's probably global if you think about it. But in the U.S., there's so many universities that are just gearing up on the analytics side. I'd have to say, research it, because there's a lot out there. But I'll plug good old NJIT, and we're going after it in a big way too. So.
And there's a fair amount of variation in terms of the focus. How business oriented is it? It turns out that employers have put a very high priority on communicating effectively about analytics. There have been surveys of employers of these types of graduates, and that's the #1 thing they say they want. Some programs put a lot of emphasis on it. Others are much more oriented to just the traditional, teaching the methods, and don't worry so much about how you communicate. Some involve some programming, some are more big data oriented, some more traditional data. So there are a lot of variations, and make sure you explore it carefully before you sign up for one of these things.
Mm-hmm. Good points.
Okay, thanks, gentlemen. Quick clarification from Arik regarding Google Nest. He was visiting the privacy FAQ page, and said, at least their statement is that they do not sell their data to the utilities companies. Not sure how anybody gets around that, but I just wanted to at least bring that up.
And there was an article in Forbes suggesting that they do, so I'm not quite sure who to believe, but it's an interesting discussion anyway.
Absolutely. Sivan has a question. How can a small startup compete with large, these giant services? Any ideas related to that?
The only thing I would say is that most of the resources for doing this kind of work are, relatively inexpensive or even free. There's open source software that can analyze a lot of the data. The sensors are, dropping in price dramatically. The hardware is to analyze the data is in the cloud and much, much cheaper than it used to be. You can buy it in very small doses. I think what's not cheap and not widely available is the expertise to do the analysis. That remains expensive. And the sort of the vision and imagination of the managers. I was talking to an executive yesterday from the publishing industry, and he said, he's doing some consulting now as well. He says he goes to these companies, and they may have one application or two, but there's nobody really leading the charge in terms of saying, what can we do with these technologies in our business? And I think that is the missing link for a lot of organizations. They just don't have somebody who's able to evangelize and create a vision for how this work can be done. It could be done in small organizations just as easily, but maybe in many cases you don't have the sort of free time to think about that. You're just busy, getting product out the door. That, I think, is the challenge.
I've noticed. Go ahead, Steve. Tom handled it pretty well.
Okay, great. Howard mentions that given that the sale of data is not often a core competency of many firms, to what degree do you foresee the rise of data brokers to facilitate that development of use cases and the transfer of data from one company to another?
I don't know, Tom. I'll leave it. That goes with privacy and what have you. That's a tough one. I consider it the Wild West right now, and the future of that, there's a lot of potential. This idea of connecting the dots, so many touch points with consumers, and so many touch points with different processes, where the broker of putting it all together and selling it, there's potential, but I just don't know what the future of the strength of privacy is. If it's going to.
We've been talking about the emergence of these data brokers that could integrate lots of data about consumers or whatever, and protect them, maybe even deliver some value to consumers in exchange for the data that they give up, but they haven't really emerged. I suspect Mark Meyer and Mike Zak were talking about it in 1996. We're still talking about it in 2016 as something that could happen in the future. They clearly exist for selling consumer data to businesses, but in terms of protecting consumers and really giving them any value for the data that they give up, we haven't seen a lot of it thus far. And I think it's fair to say that even maintaining accuracy of consumer data has been a real problem. If you go to some of the companies like Axiom that do provide you with some insight into what data they have about you, it's pretty scary. I found out, for example, that I was Asian and that I liked knitting products when I went to their database to tell me about the data they had on me, neither of which is very accurate.
You don't like to knit, Tom? I'm just kidding.
As I get older, maybe I should take it up. Maybe there was a predictive model they were using.
Right. Just a number of kind of thoughts from Carl. He says that thinking first is great. However, we need to be careful not to overthink and losing our place in the market. What about how important is acting on a gut feeling or a hunch? And again, going back to the concept of finding your niche market. What do you think about that?
Let me hit the thinking just for a little bit, and Tom, you can fill in. But I still think there's great importance to the thinking, the definition stage. If you put the time in the definition stage, everything else flows smoothly from there on out. And I understand this whole lean issue, to time to market and the quickness. But if you're going to spend any time at all, it's going to be on the definition stage. What do you want to better understand, or what's your data product going to be all about? The better you define it, and you may take a little time in the beginning, that everything else flows very smoothly and quickly at that point. So I still like spend a little time at the thinking stage, but of course you can't overthink. You can't overthink. That's true. I don't know if you have any comments on that.
Yeah, if anything, when we talked to companies about what they were doing in this area, there was underthinking more than overthinking, and no substantial process. As I said, they did like the lean startup minimum viable product ideas, but they hadn't thought very much about it. So we found a lot of organizations that developed data products and couldn't figure out a way to charge for them, or the customers weren't really that interested in them. They were just doing it because it was possible. So entrepreneurial, fast activity is always a good thing, but as Stephan said, I think a little bit more thinking, a little bit more discussing the issue with customers and other stakeholders is, I think, worth the extra time it would take.
Okay. While you're answering that, commenting on those points, I did just distribute a PDF of the slides to our attendees, so hopefully they get a copy of that. Bill wants to know something about how effective do you think the CIO is in introducing these concepts? Do you have any anecdotes to that degree?
Well, there's some really good ones and some that are spending way too much time just keeping the lights on. I mean, I've been somewhat critical in things that I've written. Not enough CIOs are really moving their organizations into these kinds of technologies and applications. I think that they are one of the important stakeholders, but we've seen far more likely that they're focused on internal applications, and the primary activity for data products is coming from CTOs and chief digital officers and so on. So I would encourage CIOs to get engaged and take the lead in terms of adding value, rather than saying we're really only focused on internal business applications.
Yeah, the function of CIO, it's going to be tough for them. This whole digital transformation process, they're one of the focal points, but it's such a complex process, and you've got to be up to speed on not only technology but analytics, data sources. So I think, as Tom said, the CDO and other functions it's nice to have a complementary effect at that level, and just don't rest at all on the CIO. It's so many moving parts, so many things to really have to be expert in, and it's tough on the CIO right now.
Okay, thank you. Unfortunately, we could go on for another hour with all the questions that we have, but we do have to wrap it up now. So again, for the next few business days, we want our audience to please look out for a feedback survey that we'll send to you via email, and we greatly appreciate your thoughts and opinions on that. And that includes this portion of our program. Thanks again to our presenters, Thomas H. Davenport, President's Distinguished Professor of Information Technology and Management at Babson College, and a Fellow of the MIT Initiative on the Digital Economy, and also Stephan Kudybadiscuss, Associate Professor of Business Analytics and MIS at the Martin Tuckman School of Management at the New Jersey Institute of Technology. And of course, we want to thank our sponsor, Xively. Another reminder that the recording of this program and the presentation slides will be available within the next 3 to 4 business days. And we want to thank you all for attending today's program. Have a great day.